Hello, AAF students, and welcome back to your next lesson. Over the last few lessons, both video and in class, we talked a lot about, and let's see how this color goes, simplifying rational expressions, right? And so we're going to be building off of this, but there's going to be some key differences that maybe you can even think of before I dive into it right now. Right? And so when we were dealing with simplifying and we did adding, we did subtracting, we did multiplying, we did dividing, and we dealt with complex fractions, which were fractions within fractions. And a key piece was that we were simplifying, right? And in order to simplify something, you can't change it. So our only option was to multiply by 1, right? And that was really like we could re-express it, we could manipulate it so that we were able to combine things and factor and cancel and all of that fun stuff, but we were limited in what we could do because they were expressions. They weren't equations. We weren't solving for anything. Another thing that I do want to point out is in the very first intro video lesson, one of the things that I alluded to, I don't even know if alluded is the right word, or I think I directly even said it, was that if you think about a rational expression, and you think about where we're going with this when we eventually are going to move towards like looking at it as a function and graphing, right? After we deal with the algebraic pieces of how do you simplify, how do you solve, which is what we're going to do today, we are going to see like how does this apply to actually be able to develop a like a visual of it. Is this an O? I feel like that's a Q. Darn. Okay, I'll fix that. Sorry, got sidetracked. And one of the things that we talked about was going all the way back to the beginning of the year when we talked about domain busters, right? And we had some key things that we had to look for. And yes, right, one of them was that we couldn't take an even root of a negative, right? That was an imaginary number, which we've learned more about. The other thing was we can't divide by 0. Right? You can't do 2 divided by 0. If you have 2 of something, I can't split it into 0 groups. That makes no sense. Right? And so that's something that's going to come up in this lesson more in depth, and then as well as when we see you next in class. So with all of that being said, the objective of this video, of this lesson, is that we're going to be able to solve, right? So now you're actually going to end up with things that are like x equals something. Equations, because there's equal signs, it's not simplifying. So this idea of this limitation that you have to multiply by 1 is no longer true, right? If I have 2x plus 5 equals 10, you can subtract 5 from both sides. I can multiply everything by 2 if I want it, right? I can multiply everything by 1/2 if I want it. But you have to do it to everything. But that limitation of multiplying by 1 is no longer there. And so we're going to be, solving rational equations using our knowledge of factoring, still really, really important, simplifying, right? We want to know what we learned over here, and working with fractions in general, right? And once we arrive at solutions, we are going to check the solutions that we found. And that is a key piece of it. Right? Some of you guys I've seen on things you've done and you've done in the past, and maybe we just haven't seen it, and more of you guys do this, but sometimes you'll get something like x equals 2, and we'll see you all plug that back in, right? You did this when we dealt with, didn't we do this with square roots? I think we did, right? We want to see like, are there solutions that don't actually work, right? Whether you're plugging it back in or you're looking at things like, what can't x equal is a really good way to begin to approach these. So after I wrote over this, I just stuck this on this PowerPoint to remind you all. So after you watch this video lesson, this right here is your homework assignment that you're going to be completing and submitting. It is all odd problems. So, what does that mean? Oh, I can check my work in the back of the book. Please do so. Use it. Use it as a tool. You're not limited to just these problems, right? This kind of then pushes you in. Well, if I'm looking at page 381 and I need more practice, use it as a resource for more practice. Okay, really, really good idea. So, rational equations. solve rational equation. So I want to end up with something where it's x equals. I don't know how many x values I'll have, right? But you can see now I have something. I'm adding together two rational expressions, and they equal to another one. Okay, so here's our steps for success. First thing we're going to do is our favorite thing, factor. Okay, what do I have to factor? Oh, the right side of the equation, right? That right side denominator. So I can rewrite this as x minus 2 times x plus 3, right? That's that in factored form. You might, maybe you've just gone ahead and maybe you've already done that homework before you even watched the video. Totally possible. There's multiple ways to do this. Maybe you're going to get a common denominator, and then once we have a common denominator, if the denominators are equal of two fractions, then the numerators are equal, right? Not a bad thing to think about. What I'm going to choose to do is I'm going to figure out what x can't be before I even try to simplify, right? This is a really good place to start instead of ending with this, so that you're aware of like, what is not in my domain? What can x not equal? Well, we just talked about this, right? We're going to set the denominators equal to 0 to see what needs to be kicked out of the domain, okay? So we know that x cannot equal to 2 and x cannot equal to -3. We use the zero product property there. And that's a really important thing for us to come back to at the end, right? If I solve this whole thing and I get that x equals -2, x equals 2, that's actually not a solution, okay? Because it can't, right? So I'm getting these using the zero product property. Find the least common multiple, just like we did when we were adding and subtracting. Well, what would that be? Oh, x minus 2 times x plus 3. I think I hear some of you guys, right? And what we're going to do, instead of just getting a common denominator, is we're going to multiply everything. Everything. Let me get a highlighter. Well, this is weird. What color do I highlight with? I'm going to multiply this. I'm going to multiply this. And I'm going to multiply this by this least common multiple. Instead of just trying to make them all have a common denominator, I'm going to get rid of the denominator. I'm going to eliminate it. Okay, I'm going to multiply each term on both sides of the equation by the least common multiple. So what's going to happen? I said I was going to eliminate it. Well, these are going to cancel. These are going to cancel. And this is legal because I'm doing it to everything, right? It's not an expression. It's an equation. This is going to cancel. This is going to cancel. I no longer have to deal with a fraction. Is the nice part of this methodology, right? Equations means I don't have to multiply by 1. That's what it means. Did we eliminate the fraction? Absolutely, right? Went away, went away, went away, went away. So now we're just left with, well, how did I get to this? Let's back up for a second. X times x plus 3, right? Get that and distribute it. That gives me x squared plus 3x plus, right? So like these go together and then these go together. That gets distributed. 2x minus 4 equals to 10. And now it's an equation that you know how to deal with. It's no longer a fraction, right? We have the ability to do that. Now we can solve this for x and discard any extraneous illegal solutions. Well, what were our extraneous solutions, if we remember? 2 and -3. Okay, so let's see. How did we get to here? Let's back up for a second. X squared plus 5x minus 4 equals 10. Well, I'm going to subtract 10. X squared plus 5x minus 14 equals 0. Right? I'm not dropping this equal sign. If I dropped an equal sign, it's no longer something I can solve, that it becomes an expression. Do not drop it. Right? That's mathematically incorrect if you drop the equal sign. So this is x plus 7 times x minus 2 equals 0. I still haven't dropped it. Don't drop it. X plus 7 equals 0. That gives me this. X minus 2 equals 0, that gives me this, right? If two numbers multiply together to equal 0, one of them has to be equal to 0. I'm using the zero product property. There is no like 1 product property or 7 product property or 10 product property. It's the zero product property. Okay, so are both of these my solution? Should I circle them and move on? No, that's not a solution. That's called an extraneous solution. That might be, is that a new word? No, I'm blanking if it is. Well, if it is, add this to your vocab. I don't know if you have a vocab list, but if you do, add it. Right? It's an extraneous solution, so x equals to -7 is my solution to this. There's only one. Okay, let's do some examples. Okay, so let's think about what we did. What do we need to kick out of this? Right, I factored the right side, factored. Well, I'm gonna know that I need to kick out of my denominator right now -2 and 5. I can't divide by 0. I can have a numerator of 0, I can't have a denominator of 0. So these right here are just important for me to remember as I progress through this. Okay, so how did I get from here to here? Well, I found the least common multiple, just like you did for adding and subtracting, and I multiplied everything by it. Right, I multiplied this one by x times 2 times x minus 5. That made these cancel, and I now have x times x minus 5. I multiplied this by x plus 2 times x minus 5. X minus 5's cancel, and I got plus, pay attention to the sign, 7 times x plus 2. And then I multiplied this one also by that least common multiple. If you want to get a common denominator, and to just recognize that if the denominators are equal, the numerators have to be equal, and almost ignore, you can do that, right? When you're ignoring, you're actually really eventually multiplying through by it, so you're creating an extra step for yourself. But it's totally fine if that's how you're thinking about it. Okay, and then here I can go ahead and distribute, and I get x squared minus 5x plus 7x plus 14 equals 14. X squared, this gives me 2x, and then I would subtract 14 from both sides. Sorry, I wrote the 14 wrong, which is where I got 0. Okay, I'm going to be careful here. If you want to, I'm going to factor out what's common. I can factor out an x, right? And I still have two factors, x times x plus 2. Go ahead and use the zero product property. X equals 0. I didn't drop the equals. It never goes away. Equal, like you can't drop it and then just assume that it means it equals to 0. That's not what happens. You need it there. So I can use the zero product property and I get 0 and -2. But I'm going to go back and think, did I just get something that was extraneous? Oh, I did. Right? It can't equal -2. Can't equal -2. So my solution is just x equals 0. Let's do another. If you haven't paused, maybe think about pausing. Okay, so let's see. Is there anything I can factor? Like I can factor a 2 out of the numerator. I don't know that it does anything for me because then I get x minus 2. So I don't think I'm going to factor anything out. Instead, I'm going to multiply everything by my least common multiple of the denominator. So x minus 1 times x plus 2. And then this one too, x minus 1 times x plus 2. It's got to go to everything. That means this x minus 1 is going to cancel. This x plus 2 is going to cancel. And I'm out of a fraction now. Oh, sorry. I thought I was going to animate it in. So now I've got 3x plus 2 times x plus 2 plus 2x minus 4 times x minus 1 equals to 5 times x minus 1 times x plus 2. Let's multiply everything out. 3x squared, 6x and 2x is 8x plus 4, plus 2x squared minus 2x minus 4x is minus 6x plus 4 equals to 5 times x squared, 2x minus x is x minus 2. Combine some like terms, I've got a 5x squared, right, from these. 8x minus 6x is plus 2x. 4 plus 4 is 8, equals 5x squared plus 5x minus 10. Let's put everything on one side. If I subtract 5x squared from both sides, it goes away. How nice. I'll subtract 5x, and I get negative 3x. I'll add 10, and I've got 18, and it equals 0. I could sit here and factor. That's a little silly. I'm going to actually subtract 18 and then divide by negative 3. And that gives me 6. And let's see, I know what I forgot to do. I didn't actually say what I was eliminating to begin with. So let's see, x minus 1 cannot equal to 0, and x plus 2 cannot equal to 0. So x cannot equal to 1 or negative 2. So this one's fine, right? I checked it. It works. If you haven't paused the video and tried one, try this. I'm gonna go ahead and clear my screen. And I'm gonna do better this time. I'm gonna start off by figuring out what am I eliminating. So x minus 1 cannot equal to 0. So that means x cannot equal to 1. Okay. 1 minus x squared cannot equal to 0. So 1 cannot equal to x squared. So that means x cannot equal plus or minus 1, right? When you square root both sides, it's plus and minus 1. And then x plus 1 cannot equal to 0. So x cannot equal to negative 1. So ultimately, I've got x does not equal to 1 or negative 1. Okay? So I can actually factor this. This is difference of squares. And so I'm going to go ahead and do that in my first step. X minus 1 minus 2 times 1 minus x, 1 plus x. Oh, isn't that just that? Good thing I did that, right? And then 8 over x plus 1. I'm going to do a little more before I start multiplying through by things. I'm going to change this one right here. I'm going to factor out a negative 1. Okay, and when I do that, this becomes positive, this becomes negative, this becomes positive. All right, so that's what I'm going to do in that step, because what that gives me is then I have, this is just x minus 1, right? So I can go ahead and multiply each one by x minus 1, x plus 1. And I have now a plus sign here. That's what that does for me, right? And so I don't need to work as hard to get a common denominator. This one I'm going to multiply by x minus 1 times x plus 1. And they're both going to cancel, right? That's it goes away. X minus 1 times x plus 1. And I'm going to cancel the x plus 1s. And so now what am I left with? On the very left fraction, I have x times x plus 1 plus 2, right? That's now a plus because I like osmosised out a negative 1. Factored is what happened. Just like that word. Just a 2, right? Equals to 8 times x minus 1. All right, so I've got x squared plus x plus 2 equals 8x minus 1. Let's go ahead and put everything on one side. I've got x squared minus 7x plus 3 equals 0. Right? I think my math is right. Oh, it's 8x minus 8. I knew something didn't make sense. So if I add 8, is this a 9? No, this is a 10, which makes more sense. I was going to say it doesn't factor. Oh no. X, but we're not afraid of that because we have other ways. So I've got x minus 5 equals 0. I'm never dropping that equal sign, ever. I got 5, and x minus 2 equals 0. I got x equals 2. I believe that neither one is extraneous, right? These were the things I kicked out. So here, we got it. Okay. So we did some practice. You got to do some practice on your own now, right? So you do have a way of checking your work once you're doing these, because you have odd problems assigned and you have resources to provide you with more practice that I encourage you to take advantage of. So in this lesson, what we did is use our knowledge of fractions and some of the things that we know about functions, right? And just like basic operations of you can't divide by 0, right? Pulling back those domain busters from first semester to successfully solve rational equations, right? Equations is the emphasis, that equal sign never gets dropped, right? In order, and as well as check for those extraneous solutions, which that might be a new word. So add that to your list of things to start using if you haven't used that, which I feel like we have, extraneous solutions. So as a reminder, this is your textbook homework that you're submitting to us before we see you next. And other than that, thanks for watching and doing some math with me, and we will see you next time in class.